Okay, a final word on binomially distributed variables, and specifically what is their mean, what is their variance, and what is their standard deviation. So in this example that you see here, we have n equals 20 coin tosses, and let's say the success probability is what it should be, like 0.5, a fair coin. Then if you flip the coin 20 times, what is the most likely number of heads? And that would be the mean. So in this case, the mean, if you flip a coin 20 times, then, let's say you flip it once, 20 times, and you record the number of heads. Maybe you get 10. Then you flip it again 20 times, maybe this time you get 9. Then you flip it again 20 times, maybe the next time you get 12 heads. Maybe you get 18 heads, which is not very likely, but could happen. But the mean is 10 heads. That's the most likely outcome. So the mean in a binomially distributed variable is n times the success probability. Okay, so that means if you flip a coin 20 times, you will expect 10 heads on average. If you flip it 100 times, then you will expect on average 50 heads. But of course, it's also likely that you get 49 or 53 if you flip a coin 100 times, or maybe 60 times. So there's a variation around it too. And the variation of a binomially distributed variable, the variance, is n times the success probability times the failure probability, 1 minus p. So if we have 20 coins, if we do 20 coin flips, so then the variance would be 20 times 0.5 times 0.5, which is 10.5. So that would be the variance. Well, and then the standard deviation is the square root of the variance. So that's the square root of n times p times 1 minus q, which in this case would be the square root of 5. In the example that I did in the previous video, we had n equals 100, and then the mean would be 100 times the success probability 0.5, 50. So on average, we can expect 50 heads. So we flip a coin 100 times, and then we do that 1,000 times. Then the most likely outcome is 50 heads. The variance would then be formula 100 times 0.5 times 0.5, so that would be 25, and in this case the standard deviation, which is the square root, would be 5. So, but of course, if you had like a different success probability, maybe like if the success probability were 0.8, then the mean, so assume p were 0.8, then we would say that the mean is n times p 100 times 0.8. So that would be 80. The variance would be 100 times 0.8 times 0.2. So that would be the variance, then would be 80 times 0.2, that's 16. And the standard deviation would then be only the square root of 16, which would be 4. Okay, so that will become useful again later, because sometimes we can actually use the binomial distribution in order to approximate the normal distribution. And we have already seen in the previous video that sometimes the normal distribution or the binomial distribution, especially when the success probability is 0.5, looks very much like a nice bell-shaped distribution. But we will come back to that again later. So we'll just stop here with the binomial distribution and continue the next video with the Poisson distribution. And in the next videos we will not go as much into details anymore. The most important discrete distribution is probably the binomial, but you should know the other ones too, so that's why we cover them.